Alright, this is our video for section 2.1 on relations and functions. First thing we're going to do is we're going to get some vocabulary words. We're going to start with relation, and a relation is a set of ordered pairs. And there's two ways that you can see a relation. First way is just a bunch of points, ordered pairs listed out in a group. Okay, that's one way to see them. Second way is as an equation. And if we graph an equation, most likely it's going to be a line. Okay, we will focus on some other things later on in the year, but for this particular section, it's just going to be lines. Maybe a parabola, but primarily lines when we look at our equations. But those are the two ways you can look at a relation. It's a set of ordered pairs, and they can be a group of points, or they can be a bunch of points connected together to make a line. Now, we also need to know domain and range, which are things you guys should already know. The domain is all the x-coordinates from a relation, or all of the x values. Okay? The range is the opposite. It's the same idea, but instead of the x's, it's going to be the y's. The y-coordinates. From a relation. Okay? Now, remember that if you look at our coordinate plane over here, we'll be graphing some stuff today. Your x-axis is the one that goes horizontal. So when we talk about the domain, it's all of the values that we use on the x-axis. And when we talk about the range, it's all the values we use on the y. And remember, points or ordered pairs are always written x comma y. Alright, so let's look at example 1. Our first example is going to be a relation with points. So we've got a set listed out here. This is a relation. We have a curly bracket, and then we have a bunch of points listed inside. We have -6, -2, -2, 5, 0, 0, which in case you've forgotten is the origin. That's where the x and the y-axis meet. 0, 2, 3, -6, 4, 0, and 6, 2. And then we close that with a curly bracket. The curly brackets indicate to us as we're looking at it that that's the set. That's all the points we're going to use for this particular problem. Alright, so first thing we want to do is graph them. So -6, -2, we would go up here. We're going to move left and right first because that's where the x value is. X is -6. And then we go down 2 because it's negative. So there would be our first point. Second point, -2, 5, to the left 5, or sorry, to the left 2, and then up 5. Put a point. 0, 0 is the origin. 0, 2, since x is 0, we don't move left and right at all. And then we're going to go up 2 because it's positive. 3, -6, to the right 3, down 6 because it's negative. 4, 0. For this one, we're going to move left and right, but we won't move up and down. So we go to the right 4, and then we're not going to move up and down because y is 0. And then our last point is 6, 2. Right, and that would be graphing our relation, our set of points. That's all we would do. Now, I also want to give me the domain and the range. Now, that's what the D and the R stand for. A couple things before you give me the domain and range. This applies to both of them. You need to give that to me in numerical order. So we start with the smallest. And I don't want any repeats. So if you have a number that happens twice, I don't want to see it listed twice. I only want you to list it once. We're going to start with the domain, which we just learned is all of the x-coordinates. So I'm going to look at my graph. It's easier for me to look off the graph. You can look off the points. Doesn't matter. All you're going to do is list out the x's. But if I look at my graph, I can go from left to right, the order that they need to be listed in, smallest to greatest, and I can see which values we're going to use. So I'm going to start on the left, and I'm going to go from left to right. Curly bracket. First number we use is -6. Then we use -2. 0, notice 0 gets used twice in two separate points. I'm only going to list it once though. And then 3, 4, and 6. And there would be our domain. That's all we have to do. Range is the same idea. I want to do the y values this time, and they need to be smallest to greatest, and then no repeats. So instead of going left to right, I'm going to go from bottom to top. So I start at the bottom. I got -6. We go up to -2, 0, and again for this one, 0 gets used twice. It gets used in this point and the one with the origin. So it's used twice, only use it once. 2 also gets used twice. So we're only going to list it once. And then 5. We close our brackets. That's giving the domain and range for that set of points, that relation. And that's all we have to do. Let's look at our next example. Is a little different. We have an equation, which means when we graph it, it should be graphed as a line. It should all be connected, and this is a common mistake. Anytime you are given an equation, you need to connect your points, and your domain and range will be a little different. If I just give you a list of points, like we did in example 1, you do not connect them. But if I give you an equation, you have to connect. Alright, so let's graph this. And for some of you, it may be easier. You may remember back to Geometry Algebra 1, where you use slope-intercept form. That's fine. If you want to do that, that's fine. There's nothing wrong with that. Haven't taught that to you yet in this class. We will learn that, but if you remember it, great. If you don't, this is how I want you to do the problem. We're going to make a chart. Got our x. We're going to have a column for work, which you may not need to show because you could probably do it in your head, and then a y column. So for our x values, we're just going to pick some points. Some values we're going to plug in for x and see what answers we get, which will be our y's. I'm going to pick the numbers -2, -1, 0, 1, and 2. Those are typical numbers we'll pick, those 5 values. So it's a good habit to get into using them now. Alright, -2. If I plug -2 into our equation here, x plus 1, it'd be -2 plus 1. -2 plus 1 is -1. So my point is -2, -1. And then I would graph that. -2, -1. Next one, I'm going to plug in -1. -1 plus 1 is 0. So my point is -1, 0. Because I'm listing them out as ordered pairs, x's and y's. Graph that. If I plug 0 in, 0 plus 1 is 1. My next point, 1 plus 1 is 2. And then 2 plus 1 is 3. So 2, 3. And we put them, and then since it's an equation, I connect my points. And there would be the graph for this relation. Now, what's different on these is the domain and the range. Okay? The reason it's different is because it's connected. It makes a line. If we think about it, a line's going to go on forever. So it doesn't matter what value I plug in for x. I can plug in any number I want, and it's going to get used. Any number I plug in will give me an answer, which means there are an infinite number of answers there. And the way we show that is we say x, comma, x, an E like that, and then an R with 2 lines. That stands for all real numbers. And what that means is that it doesn't matter. I can pick any number I want. Any number we put in there is going to be part of that graph. Any number from negative infinity to positive infinity. I could plug in 2,000, I could plug in -4,000,007, and I'm going to get an answer. It's going to be part of that line. Okay? The range is the same way. If we look at it, any y value is going to be used. So I don't use x's, I use y since it's the range, and I write it the same way, which means all real numbers. Now, I don't care if you put it in the brackets and write it like that, or if you just say all real numbers. Remember those brackets? That's set builder notation. Okay? I don't care how you say it. Typically, you need just need to be aware that you could see both written someplace. Okay? That both are acceptable answers. Alright, next thing we're going to talk about is what a function is. And the formal definition for a function is where each x goes to only y value. That's the formal definition. What that means is that each x you plug in gives only one answer. So if I plug the number 5 into my problem, I get one answer when I do that. That's what it means. Another way of thinking about it is that there are no repeats in the domain, which is the same idea. Okay? If I plug a number in, I should get one answer. That answer shouldn't repeat for anything else. Okay? So that's what it means to be a function. A one-to-one function, kind of the same idea, it's just flipped. Where each y comes from only one x. Okay? So my answer, I can only get a particular answer to a problem by putting in one x value. One number will only give me that answer. Okay? It's the opposite way of thinking about what a function is. It's just flipped. Okay? One thing about a one-to-one function, and this is really important, it must be a function first. So if for some reason you don't have a function, then it's automatically not one-to-one. Okay? I can have a function and it not be one-to-one, but if it's not a function first, then it's not going to be one-to-one. Now you can think of a one-to-one function the same two ways you think about that I gave you to think about a regular function. We said no repeats in the domain. For a one-to-one, it's no repeats in the range if you've listed it out. Okay? And that's what a function and a one-to-one function are. We are going to go back to example 1 and example 2, and we're going to talk about whether they're functions and whether they're one-to-one functions and talk through what that means. Alright, so here's example 1. I've listed out your points again. It's a relation, remember, at this point. And we've listed out all of those points. I've also given you the domain and range because we've done that. We've listed that out already. Remember, I told you that a function cannot have repeats in the domain. Well, if we look, our x values, we had 0 that got used twice. Since 0 was repeated, this is not a function. Okay? I can plug in 0 and I can get this answer. I can plug in 0 and get this answer. Okay, that's what it means when we say for each x we plug in, we only get one y value. In this case, we got 2. I plugged in 0 and I could get 0 as my answer, or I could get 2. It gave me 2 numbers, 2 y values. Second part of this is easy. Since the first part, since it was wasn't not a function to begin with, it's automatically not one-to-one. Okay? Again, one-to-one has to be a function first. If it is a function, then we check for repeats in the range. But since it wasn't a function to start with, it's not a one-to-one function. Let's look at example 2 now. This is for our graph. Now it's a little different since we had an equation. We're going to use something called the vertical line test. And what the vertical line test says is if you can draw any, and that's important, any vertical line that intersects the graph only once, then it's a function. Okay? Now, the reason I pointed out any is it has to work for whatever line you can come up with. It has to be a vertical line you draw, but it has to work in any place that you draw the line. So let's look at our graph. We can draw vertical lines anywhere on here, and it's only going to intersect once. So yes, this is a function. If we had a graph like this, like an S, I would draw a line and it intersects 3 separate times. This would be a no. That's what the vertical line test means. So if I can draw a vertical line and it intersects only once, then yes, it's a function. And it's easier to do that when you have a graph to start with. It saves you some time. You don't have to list out the domain and range. Now, one-to-one. 1-to-1, we can use the same idea as the vertical line test, but remember, 1-to-1 deals with the range. A function deals with the domain. We're looking for repeats in the domain. 1-to-1, we're looking for repeats in the range. So we wouldn't use a vertical line test, we would use a horizontal line test. Same idea as vertical, except I'm checking for horizontal lines. So I could draw any horizontal line through that graph, and it would only intersect once. So yes, it's 1-to-1. Hopefully that makes sense. That's an easy shortcut to use if you're using a graph, if they give you a graph to start with and ask if something's a function. If they don't give you a graph, you can graph it. If they give you a bunch of points, you can graph it and still use the vertical line test. It'll do the same thing. Alright, but it's an easy shortcut to remember. The last thing we've got on here is a practice problem. So I'm going to read the problem to you. I want you to pause it and then try it on your own and come back and check. Notice our problem is y equals x squared minus 2. Now I want to point out something. We have a variable of 2, or an exponent of 2 on there. That tells us this is not linear. Alright? I'm going to go ahead and tell you that this is a quadratic. And if you can remember back to geometry, we did talk about this. We talked about it in Algebra 1 too. And the shape of this is going to be a parabola, which is that U shape. It could open up, it could open down. Alright? So we aren't going to get a straight line here. But I gave you an equation to use. So it is connected. Alright? The points that you get, you are going to connect them to make, it's not going to be a straight line, but you'll connect them to make a graph. Okay? There are 4 things I want you to give me. I want you to give me the domain, the range, whether it's a function, and whether it's 1-to-1. So go ahead and pause this, work the problem out, and then come back and check. Alright, let's work this out. Let's see if you got the right answer. There are some catches in here, some little tricks that I want to point out. So make sure that if you didn't get it right, you understand what's going on. We're going to make ourselves a chart. The x, work, and then y. We're going to use those same values we did earlier. -2, -1, 0, 1, and 2. Alright, so let's plug in -2. -2 squared minus 2. Well, -2 squared, anytime I square negative, it's going to be positive. So -2 squared is positive 4 minus 2 is 2. So there's our first point. -2, 2. Let's plug in -1. -1 squared minus 2. Well, -1 squared is going to be positive 1 minus 2 is -1. Oh, I made a mistake on this first one. No, I didn't. It is positive 2. Second number is -1, though, so we get -1, -1. Plug in 0. 0 squared minus 2. 0 squared is 0. Common mistake. 0 squared is 0. If I had something to the 0 power, it is 1. So if I had like 10 to the 0 power, it's 1. But if I have 0 to the 10th power, it's 0. Alright? So 0 minus 2 is minus 2. 1 squared minus 2 is minus 1. And then 2 squared is going to be 4 minus 2 is 2. So our last 2 points are 1, -1, and 2, 2. And we're going to plot those. -2, 2. -1, -1. 0, -2. 1, -1. And 2, 2. So we get this shape, and we're going to connect them. And I told you it's going to make that U shape, that this is a parabola. Okay, because it's a quadratic. So we're going to list out now our domain, our range, whether it's a function and whether it's 1-to-1. I'm going to start with function, because function is probably the easiest. We're going to use that vertical line test. I can draw any vertical line on that parabola, and it's going to only cross once. So yes, this is a function. If I draw a horizontal line, though, it's going to cross twice. So no, it's not 1-to-1. Next thing we want to do is give the domain and range. The domain is all the x values we use. If we look at our graph, this is going to continue to go out in both of these directions, to the left and to the right. So every x value is going to get used, which means it's all real numbers. So x, X, E, and then R, all real numbers. The range, however, is not all real numbers, and this is what catches some people. If we look, it only goes to that point, that -2, and then it turns around and goes the other direction. So it's not all real numbers. We're not just going to list out the values that are greater than -2. We're going to write it in set builder notation. We're going to say y such that y is greater than, and we want to say equal to because it does hit at -2. Greater than or equal to -2. And we close it off. Alright, that's the range. All of the y values that are bigger than -2, because those are the only ones that we actually used in the graph. Alright, well those are your notes for section 2.1 on relations and functions. Important things to remember: points you do not connect. If it's an equation, you do, so you'll have a graph with a line. And the vertical line test. It tells you whether it's a function or not. Remember what is a function, what it means to be a function, and what it means to be one-to-one.